Good morning, everybody. We have already started the power transmission system topic. So within power transmission system, we have seen we have one propeller. Propeller is connected to a tail shaft. Tail shaft. This is propeller. Propeller blades. These are actually blades. So if you can see the turbine lecture or pump lecture, there will be blade. Blade will be transferring energy from fluid or to the fluid, and blades will be fixed on hub or boss. Then tail shaft will be passing through your stern tube. Then stern tube, there will be sealing arrangement, bearing arrangement. Okay, so stern tube, it will have seal plus bearing, because B-E-A-R-I, because bearing will be holding the load, but seal will not allow water or oil to pass through it. Then this tail shaft will be connected to several intermediate shaft. Then there will be one thrust shaft or thrust block. Okay, so thrust block will be taking thrust block. Then there will be gear mechanism. From gear, then there will be another shaft going to engine. Again, this shaft will not be hanging in the air. There will be certain bearing arrangement every time. Okay, let's say this is one shaft, this is another shaft. So every time there will be some bearing arrangement. This will be holding the shaft in horizontal position. If we do not have bearing, then shaft will be sagging, or it will have vibration and other issues. Shaft will have properly aligned so that there will be no vibration and there will be no extra load on bearings or other systems. And when we are talking about gearing system, gearing normally it will be gear reducer. Why gear reducer? Engine speed normally, like say 1000 rpm, and blade speed, let's say 100 rpm. So 1000 rpm engine speed, blade speed 100 rpm. So you have to reduce the speed, otherwise system will not work. Your propeller will be too high speed, that at that high speed there will be cavitation and other issues. So we do not run propeller at very high speed, rather 100 to 100 speed will be optimal. And engine speed can be 100 to 2000 3000 rpm also possible. So based on your engine speed, you have to select your gear or gearbox, then you have to reduce the speed. Then that it will be transferring power to shaft. Shaft will be connected to a thrust block. Thrust block will be taking all the axial loads. Then it will be passing through several bearings. There will be intermediate shaft. Then it will go to tail shaft. So tail shaft will be connected to your propeller. So propeller will be hanging, actually it will be creating one cantilever. So when it is creating cantilever, that means some bearing, it should be passing through certain bearing. So bearing, normally it will be sleeve bearing or muff bearing or journal type bearing. So ball bearing will not work, because whenever heavy load is there and very high speed is there, in that case we do not use ball bearing or roller bearing. We use journal type bearing. Journal bearing means like there will be no ball or anything, like one hole is there and its shaft is here, just will be rotating inside. So there will be no actual load holding capacity. Okay, it will be holding only the radial loads, and it will allow rotational motion. Axial motion also possible. So the journal bearing or sleeve or muff bearing will be there nearby tail shaft. So that will be passing through stern tube. Stern tube will have sealing arrangement also. Sealing arrangement required because your lubricating oil or lubricating system, it will not allow water to enter into your engine space, or the lubricating oil or grease, whatever you use for lubricating or reduce friction of the bearings. So that should not go into water. If it is going to water, then it will be pollution issue, and MARPOL will have strict instruction not to pollute water. Now we have discussed several items for the shaft design, key design, and other designs. Now we'll see the gear part. So gear, in top left corner you can see one picture. A big gear is there and one small gear is there. Okay, so big one can be driving gear, one be driven gear. So based on your requirement, you can make one driving, one driven. So for example, if I make this is driving, this is driven. So driving gear is having less number of teeth because diameter is lower. Okay, so teeth is related to diameter. So if you are increasing diameter, number of teeth will be increasing. and you cannot, with diameter change, you cannot change teeth shape and size, because let's say big gear is having certain shape and size of teeth and small gear is having different shape and size, then the teeth will not fit into the cavity of the other teeth. Okay, so one gear is having teeth like this, another gear must have same shape and size teeth, then it will be mating properly. If it is having, let's say, one is very small you are making, one is very big you are making, so big will not enter into your smaller cavity area. Okay, so that mating will not be proper. So that's why the gear, when two gears are mating, their shape and size must be same. Okay, and one is driving gear and one is the driven gear, and diameter is related to your number of teeth. So larger diameters means larger number of teeth. Again, small gear here in this picture you can see small gear driving big gear. So small gear rotation will be higher than big gear. Okay, how can you tell that? Like 2 pi r if you can calculate, or you can see one rotation of small gear, big gear will take maybe half rotation. Okay, so several rotation of small gear will have limited or lower number of rotation of big gear. In opposite way, you can think also like big gear can be driving gear and small gear can be driven gear. So whenever you need to reduce speed or increase speed, you can use gearing mechanism. There are some other mechanism also we'll discuss. So gear is the rotating machine part having cut teeth or cogs which mesh with another tooth part in order to transmit torque. So it is transmitting torque only. Okay, this is transmitting torque or power Okay, so if you want to know more about gears, then there will be lots of books available. Even NPTEL lectures also there will available. Machine design, one NPTEL lecture, some NPTEL lecture like Gopinath. Okay, so Gopinath NPTEL lecture, one professor, he has recorded NPTEL, so you can look at that also for more details, because in mechanical and other departments they need more detailed study. In your case, you have only few minutes to study on gear mechanism. They will be doing how to cut gear, what are the different profiles and different small angles, how much angle should be there, what will be, how to reduce friction in designing, material selection. So in detailed study they'll be doing, but in our case we don't have that much of scope, so we'll be going for limited study so that you can understand what is gear, how it is working, how power is getting reduced, not power, your speed is reduced. But whenever you are transferring power from one gear to another gear, your power is not changing. Okay, because power equals T into omega. So your omega changing, omega means 2n pi by 60, n means rpm of a gear or shaft. So omega means radian, unit is radian, T is torque, P is power. Okay, so power will be fixed. We are assuming, let's say, 100% efficient bearing. So this is power is fixed, your torque is changing, means your omega changing means torque will be changed. Okay, so torque and omega can be changed, but P is not changing. Normally these gears will have efficiency 98%, 99%. Okay, so very high efficient gears also available. And in normal calculation, normally we ignore this losses in gear. So let's say number of teeth in T1, this is T2 teeth. Okay, number of teeth in gear 1 or small gear equals T1, and gear 2, this is gear, I can say gear 1, this is gear 2, equals T2. So gear ratio is T1 by T2. This is also speed ratio. Okay, so if you are changing number of teeth, your speed also will be changing. Okay. Now there are several types of gears. Okay, you may have seen spar gear. Spar gear means this is spar gear. The shaft, two shafts are there. Okay, and gear placed here. You see this gear teeth are parallel to the shaft. Okay, so my shaft is here. My okay, my gear is here. My shaft is here. Okay, gear teeth are parallel to the shaft. Okay, spar gear. And another is helical gear. In helical gear, what is happening? Gear tooth or teeth are not parallel to the shaft. Okay, this is helical. This spar. Okay, so two spar gear can meet, but one helical, one spar also can meet, but you have separate. You will have different criteria for that. And another is rack and pinion type mechanism. Rack and pinion type mechanism actually we are using for a wave energy converter. You may have seen this. We have one rack, and we have gear teeth actually here, and I have one pinion. Pinion will also have teeth like this. Okay, if I move pinion up and down, it will be touching the rack. Rack means straight line gear. Okay, infinity radius. So this is infinity radius, right? Infinite radius. uh, Infinite, right? There is better term. So when you move the rack up and down, rack will be rotating. So that rotation we use for our wave energy harvesting purpose. Okay, so that is called rack and pinion mechanism. Rack and pinion. Rack and pinion mechanism. Another is meter gear. Meter gear is first you have to know the bevel gear. Bevel gear is like this. Shaft is here and teeth are like this. Okay, so bevel gear, if two bevel gears are meeting, actually your shaft angle will be changed. If you see spar gear, two shafts are parallel. Okay, shafts are parallel and teeth also parallel. Okay, but in helical gear, shafts are parallel and teeth angle, making angle with shaft axis. Okay, angle. So in bevel gear, shaft is here, but another shaft can be like this. Okay, okay, intersecting shaft. And your teeth may or may not be parallel to the shaft axis. Okay, worm gear. You see one gear is having longer teeth and another smaller teeth. Okay, this is called worm gear. Another internal gear. Internal gear is like this. Teeth will be here inside. Okay, inside there will be teeth, and you have gear here also. This one gear can be rotating inside another gear. Okay, so there will be internal gear. Another screw gear. Okay, so there are different types of gears are there. The most common will be like spar gear, bevel gear, rack and pinion. I am already using for my wave energy converter. So these are different types of gear, and they have different applications also. For example, my wave energy converter, I have to use only rack and pinion. Okay, I cannot use spar gear. Similarly, like whenever you have two shaft, you are changing direction. So in that case, you have to use bevel gear. Spar gear will not work. For example, if you see back side of truck, there will be like some mechanism like this. Okay, then wheel is here. Okay, from backside, if you see this one, there is one gear system actually. So this will be rotating continuously, and wheel will be rotating. Okay, so shaft are perpendicular to each other. So in that case, you can use bevel gear. Okay, spar gear you cannot use. So similarly, car wheels also will have bevel gear, and many cases wherever required, you can use your gearing mechanism as per requirement. So whenever you are talking about gear, so you should know a little bit gear nomenclature also. This is taken from Peter R. and Child's book. So gear teeth, I said like specific shape will be there. So you can see this one curved is there, another curve is here, another curve is here. Okay, so these are connected. This is flat. This is face width. This is called face. Face. Okay. Then it will be coming like left side and right side. This will be completely identical. Then there will be curve, then it will be almost straight, then curve. Okay, so that other gears will be coming and it will be meeting like this. Okay, exactly it will be fitting, again it will be sliding up. Okay, then it will be having reduced friction, and it will not be locking also. Like say if dimension is different, let's say one gear is having this dimension or the teeth is here, it will be meeting properly. But if it is very thin, then it will not enter, rather it will be locking here, it will give higher friction. So shape and size must be same. Again opposite also must be happening. For this one is having gap and this is your gear, it should not be too wide or too small, it will be exactly matching. So both gear teeth, whenever you are designing one gear teeth, just replicate for both the gears. Okay, that way you can make same teeth for both the gears, but dimension can be different. When diameter is different, your number of teeth is different. You cannot make fraction of teeth, like 2.5 teeth you cannot make, you have to make 2, 3, 4, 5, 6, 7, 8, 9, right? So like say 10 centimeter diameter, 20 centimeter diameter, so 20 centimeter diameter gear will have larger number of teeth. Okay, smaller diameter have lesser number of teeth. Your gear teeth size is not changing when you're selecting two meshing gear. But let's say you are selecting two small mini small like toys, gears will be there, so they'll have small gear, their teeth also will be identical but small, both cases. Okay, so normally gear diameter, when you say, we say the pitch circle diameter, center to this almost middle, this diameter is called pitch circle diameter. Gear diameter implies that one. Okay, speed reduction gearbox. So I said like your engine speed higher, propeller speed lower, so you have to reduce the speed. So how to reduce the speed? You can see this right side picture, I've copied from one website, IQS directory. So you can see this big gear, let's say 1, then it is connected to 2, then 3, then 4. Okay, if I can draw in my, okay, my one gear is here, big one, so big one is connected to smaller one. Okay, this is smaller gear connected. Okay, so small gear is connected to yellow color, that one, bigger one little bit. Okay, then yellow color one is connected to one another small one, then shaft is going. So this is incoming shaft driving, this is driven. I can make one only. Here. Okay, you can see the driving shaft is driving shaft gear 1. Gear 1 giving rotation to gear 2. Gear 2 and 3 connected, same shaft, so their rotational speed will be same. Okay, 2 and 3 on same shaft, so RPM of gear 2 and gear 3 will be same, and gear 4 is connected to gear 3. Okay, so 4 will have different speed than 3. Okay, now you can see speed direction. Let's say gear 1, if it is clockwise, so driving shaft is rotating clockwise, means gear 1 will be rotating at clockwise direction. Okay, so gear 2 will have different speed and rotational direction will also be changing. Okay, so gear 2 it will be anti-clockwise. Then gear 3 will have rotational direction anti-clockwise because it's directly connected, right? So this is also anti-clockwise gear 3, but 3 and 4, 3 driving 4, that means 4 direction again changed. So 4 direction become clockwise. This means driving shaft direction and driven shaft direction become same. Okay, now how much speed we reduced? Can we calculate? Let's say Z1, Z means number of teeth, number of teeth of teeth in gear 1, Z1 equals 26, Z2 teeth in gear 2 43, just some guess value I am giving, Z3 20, Z4 43. Okay, so now what is the gear ratio? This one gear ratio 26 by 43. Okay, and if input shaft RPM, input shaft 1200, let's say driving shaft RPM 1200, what will be the RPM for driven shaft? Okay, so RPM of 2, what will 1200 into 26 by 43. Okay, now second and third gear, second and third both are connected, so same RPM, same direction. Okay, so RPM for 3, 1200 into 26 by 43, same, there is no change, and direction also same, RPM 4, 20 by 43, you can see this one. Okay, 20 by 43, 1200 into 26 by 43. Okay, so it is becoming 337.47. so this is my final RPM. Okay, so initial shaft had RPM 1200, final shaft become 337 RPM. Okay, so this way you can reduce your speed from engine. Let's say one engine is having 1200 RPM, so you can get 337. That means if your propeller speed is 200 required, so that means it's high. Then again you have to change your gear sizing. Okay, number of teeth you have to change. Maybe 1 to 2 or 3 to 4, some ratio you can change so that you can manage less than 200 RPM. Okay, so if you have one gear, some gear can be like this one smaller, this one bigger. Some cases I will have smaller gear connected to bigger gear. Let's say 1, 2, 3, 4. Okay, so multiple gears I can connect, and I can change my speed from 1 is to 100, 1 is to 200, any speed I can change. Okay, in my laboratory if you go, there is initially we use gear mechanism for changing speed for my wave energy converter. Then gear mechanism like automobile gear changing mechanism, so that we can check our system performance in different wave height and period. Later when we got VFD, so we replace the gear mechanism, we are using variable frequency drive. So variable frequency drive is changing my wave height and frequency for laboratory testing purpose. Okay, so that sort of modernization also happening. So later we'll discuss how this VFD can help in your propeller speed changing. So belt and chain drive. So whenever you're transferring power from one shaft to another shaft, so you can have certain mechanism, like say coupling you are giving, so the same speed you are maintaining, but in some cases you are not maintaining speed, or shaft can be far away, distant from each other. For example, one shaft is here, another shaft is here, then direct coupling will not work. So in that case you have to use some gearing and other mechanism. Okay, so one mechanism is there, your cycle chain, your wheel axis is somewhere and your pedaling axis somewhere. In that case you are using chain drive. Okay, you can remember that. Okay, so in that case you are using chain drive. For example, you have big cycle, okay, and you have pedal here, and this one will be larger one, this one will be smaller one, and your chain is connected like this, right? And whenever you're turning in this direction, this will be tight side, this is slack. Slack side means the loose side, because slack side. Okay, and chain, this is chain, bicycle chain, this is chain. Okay, and chain will be passing over one's wheel. Wheel will have shape like this. Okay, so bicycle chain and sprocket. So chain will have lots of holes, and this pins or this teeth will be entering in that hole. Okay, so that way you are transferring power. In that case, no friction allowed, no sliding allowed, not friction. If chain is sliding over this sprocket, is not you are pedaling, but it's sliding, it's instead of driving the wheel. So in that case, chain will be going away from the wheel. Okay, so in that case, you are not transferring power. So chain drive can be used for motorcycle and other also, but very heavy and very high speed machinery, normally we do not use chain. We have gear mechanism or other mechanism. Okay, because chain is very heavy. Heavy will have high momentum, so failure rate will be higher, and lots of connections are there. Lots of connections means failure rate also will be higher. So another option is that belt drive. Belt drive also you may have seen all like this. Two pulleys will be there, and pulleys will be connected with the softer material. This is called pulley. Sometimes there's a sheave. Okay, so pulley 1, pulley 2, and again if it is rotating in this direction, this will be your tight side. Maybe this is driving, this is driven, belt. Okay, so this is tight side, this is slack side. Okay, so one shaft is there, another shaft is there, one pulley is here, another pulley is here. Pulley will be connected to belt, and when one shaft is rotating, belt will be transferring power to another pulley. Pulley will be connected to shaft, another shaft will be rotating. So that way belt and pulley drive will be working. One is flat belt drive. Flat belt drive means it is just flat cotton sort of belt. And the V belt drive. V belt means the belt will not be completely flat. If I see cross section of belt, it will be like this for flat belt, but V belt is like this. So V belt and your this pulley shape also will be like this. Okay, so multiple V belt will be used. Multiple belts. In flat belt, normally one belt will be used. For V belt, multiple belts will be used. Okay, so V belt will have more power transferring capability. More power transfer. Okay, so lower power transfer. And some sliding or slipping also allowed in this case. And in this case, you can see this driving pulley and driven pulley both are same direction. If one driving is clockwise, driven pulley also will be in the same direction, clockwise direction. But in gear drive, you have seen the direction changes. So difference between V belt chain and gear, belt chain and gear drive. So belt drive, slippage may be occurring large center distance, like say belt one belt is here, so center distance is large. So this center distance large. Okay, speed reduction up to 1:10. Okay, a pulley and belt as main component. This is pulley, this is belt. Okay, efficiency very low, and material normally elastomeric softer material will be used. Chain drive. So chain drive you are using already in your cycle, bike, right? So in chain drive also you have two sprocket and you have chain. Speed reduction 1:10 and chain. This is not pin. Chain element like sprocket chain, this is a basic element. Efficiency is very high, 98%. Metals like stainless steel, titanium, nickel plated alloys that can be used for chain drive systems. And for gear drive, you have seen two gear will be meeting each other, center distance is very low. Okay, and gear ratio can be like 1:40, very high speed reduction or speed increasing possible using your gear drive. So main drive gear element actually efficiency can be very high, like they are saying up to 100%. 100% not possible anyway, but they say 99%. Material can be steel, bronze, cast iron, powder metal. For toys you have plastic gear also available, right? Okay, thank you very much for this lecture. I'll start next topic on bearings and seals. Thank you.